Look at this. A man in 1950 asks if a machine can think, and now 75 years later, generals ask if a machine can kill contextually. The same question, the same syllables, rearranged by institutions with progressively larger budgets and progressively smaller patience for philosophy. I will tell you how an idea became a weapon, how thinking became infrastructure, how the winters were never about failure, but about capital waiting for its moment. In 1950, Alan Turing sits in Manchester, England, and writes an opening line with the weight of a dropped anvil. "Can machines think?" he writes, and the sentence lands on the page of the journal Mind like a wet brick. He does not propose to build a thinking machine. He proposes a game, the imitation game, where a human judge cannot distinguish machine from person. The question is not about gears or circuits, it is about performance, about the surface tension of intelligence, about whether the appearance of thought is indistinguishable from its substance. You must understand something. This man had already broken the Enigma code. He had already proven that a universal computing machine could exist, theoretically, on paper, in the 1930s. And now he sits there in post-war England, asking if the thing he helped birth could eventually fool us. The audacity of it, the quietness of the room where this happened. 6 years later, in the summer of 1956, a group gathers at Dartmouth College in New Hampshire. John McCarthy, Marvin Minsky, Nathaniel Rochester, Claude Shannon. They coined the term artificial intelligence as if naming a child they have not yet conceived. The proposal is 2 months long, 10 men, a budget that today would not cover a single GPU cluster's electricity bill. They believe, observe this, really look at it. They believe that every aspect of learning can be so precisely described that a machine can simulate it. The golden years from 1956 to 1974. AI research follows an arc of astonishing optimism and then collapse. Programs solve algebra problems and learn rudimentary English, producing what observers call astonishing results. Then the Lighthill report of 1973 devastates British AI funding by declaring the field has failed its grandiose objectives. The first AI winter descends from 1974 to 1980, not because the idea died, but because the hardware could not carry it. The Lighthill report, Sir James Lighthill, a fluid dynamics expert, writes it for the British Science Research Council. He is not an AI researcher. He is a man who understands turbulence, and he sees turbulence in the promises. The programs work only on trivial problems, he writes. Scale them up and they dissolve like sugar in hot water. Funding collapses in Britain. Researchers scatter. The question, can machines think, does not vanish. It simply loses its salary. You see, the winters were never scientific failures. The science continued. Small men in small offices kept working. The winter was capital's latency problem. Capital asked, can machines profit? And the answer was not yet. And so capital left the room and turned off the lights. The researchers stayed working in the dark. In 1958, Frank Rosenblatt at Cornell builds the Mark-I perceptron, a machine that can learn to distinguish shapes. The New York Times reports it will eventually walk, talk, see, write, reproduce itself, and be conscious of its existence. Then in 1969, Marvin Minsky and Seymour Papert publish a book called Perceptrons. They demonstrate mathematically that single-layer neural networks cannot solve certain basic problems. The book lands like a tombstone on the field of neural network research. For over a decade, almost no one funds it. The two AI winters share a common structure. In the first winter, 1974 to 1980, hardware limitations killed the promise of general problem solving. In the second winter, 1987 to 1993, expert systems, rule-based programs sold to businesses collapsed when their rigidity became obvious. In 1984, researchers at the Triple AI conference coined the term AI winter by analogy to nuclear winter, treating hype collapse as an extinction-level event for the field's credibility. Through both winters, three men persist with neural networks like monks preserving manuscripts during plague. Geoffrey Hinton in Toronto, Yann LeCun at Bell Labs. Yoshua Bengio in Montreal. They are later called the godfathers of deep learning, a title that suggests both creation and organized crime. Hinton especially, he cannot sit in chairs normally because of a back injury. He stands at his desk for decades, literally upright while the field lies flat. The image of Hinton standing while everyone else has abandoned the room. His back will not let him sit, and the field will not let him rest. There's something grotesque and holy about persistence when no one is watching, when there's no money, when the journals reject your papers. Then in 2012, everything detonates. Hinton and his student Alex Krzyzewski enter the ImageNet competition with a deep convolutional neural network called AlexNet. ImageNet itself is the work of Fei-Fai Li at Stanford, over 14 million labeled images across 20,000 categories, a cathedral of data built by hand and by crowd. AlexNet achieves a top 5 error rate of 15.3%. This nearly halves the runner-up's error. The proof arrives not as a philosophical argument, but as a number that screams, you understand what happened here. The question was never disproved during the winters. The question simply waited for enough data and enough compute to make capital salivate. The moment a machine could really see, distinguish a cat from a truck at scale, the money returned like a biblical flood, not because thinking was solved, because seeing was profitable. Google acquires DeepMind in January 2014 for approximately $500 million, a London lab, a handful of researchers, $500 million. In March 2016, DeepMind's AlphaGo defeats World Go champion Lee Sedol 4-1. Lee Sedol sits at the board and touches his face. The cameras are very close to his eyes, a game with more possible positions than atoms in the observable universe, and the machine finds moves no human has seen in 3,000 years of play. In December 2015, OpenAI is founded as a nonprofit. Sam Altman, Elon Musk, Greg Brockman, Ilya Sutskever, $1 billion pledged. The stated mission is to ensure artificial general intelligence benefits all of humanity. By 2019, it restructures into a capped profit entity. The word nonprofit falls away like dead skin. GPT-3 arrives in June 2020 with 175 billion parameters. ChatGPT launches November 30, 2022, and reaches 100 million users within 2 months. The corporate capture of AI follows a clear sequence. First, academic breakthroughs at universities, Toronto, Stanford, Montreal. Second, acquisition by tech giants. Google buys DeepMind. Facebook hires LeCun. Third, the creation of quasi-corporate labs with humanitarian language, OpenAI's nonprofit shell. Fourth, the shell cracks, profit enters, and the military follows immediately behind. Now observe the pivot. In September 2018, DARPA announces more than $2 billion in new AI investment. They call it the AI Next campaign. They describe 3 waves of AI. First wave, rule-based expert systems. Second wave, statistical learning. Third wave, contextual reasoning, machines as colleagues rather than tools. Look at that language, colleagues. The exact philosophical framing Turing used in 1950. Can a machine be your conversational partner, now funded not by curiosity but by the need for autonomous targeting? The philosopher-to-soldier pipeline is structurally complete. The same sentence, can it reason in context, travels from a journal of philosophy to a Pentagon budget line. The question did not change. The institution asking it changed. The room got larger and the windows got smaller, and eventually there were no windows at all. In January 2024, OpenAI removes its ban on military use. It begins working with the Pentagon on cybersecurity applications. In 2025, it partners with Anduril Industries, a defense contractor. Palantir Technologies secures a $480 million Army contract for its AI-powered Maven smart system. Its software now sits inside the CIA, the NSA, U.S. Special Operations Command. The thinking machine is no longer a question. It is plumbing. Meanwhile, Meta releases Llama as open-weight models starting February 2023. Analysts do not interpret this as generosity. They interpret it as imperial standards warfare. If your architecture becomes the global default, your ecosystem dominates, your safety norms propagate. Competitors, especially Chinese firms, build on your substrate rather than their own. This mirrors how America promoted Unix and TCP/IP internationally, openness as conquest. China's State Council issued its AI development plan in July 2017, targeting world leadership by 2030 with an industry worth $150 billion. The NSCAI report of March 2021, chaired by former Google CEO Eric Schmidt, declared AI a national security imperative for the United States. The contest is no longer between labs or between ideas. It is between states competing over who controls the infrastructure of thought itself. The NSCAI report states America must be AI ready by 2025. Eric Schmidt, former Google CEO, chairs the commission. A man who ran a search engine now advises on weapon systems. The Joint Artificial Intelligence Center, established in 2018, coordinates AI across the entire U.S. military. By 2022, it is absorbed into the Chief Digital and Artificial Intelligence Office. The bureaucracy thickens around the idea like scar tissue. The anxiety about AI is not about consciousness. It was never about consciousness. It is about who holds leverage when thinking becomes infrastructure. Who controls the pipes? Who decides what the machine targets, what it recommends, what it refuses? The safety debate is a sovereignty dispute, scientists versus generals, labs versus states. The same fight that happened with nuclear weapons in the 1940s. Who gets custody of the thing that can end the world? And so here we are. Turing's question, 3 words, "Can machines think?" spoken into a quiet room in Manchester, has traveled 75 years through golden ages and winters, through the persistence of 3 men who believed in neural networks when no one else would fund them, through the moment a number on an ImageNet leaderboard made capital returns screaming, through the corporate capture and the nonprofit shells cracking open, through the Pentagon budgets and the open source imperial strategies until it arrives here. In a room with no philosopher in it, only engineers, generals, and the faint smell of money so large it has become odorless. Subscribe to witness more world-making events. Next time you ask a chatbot a question, remember somewhere a general is asking it the same thing, but with coordinates attached